In this notebook, we perform clustering on a wine dataset using Python and pycaret library. Clustering is an unsupervised machine learning technique used to group similar data points together. First, let's install pycaret library, which simplifies the machine learning workflow, including clustering by providing built-in functions. Step 2. Now let's load the dataset. We use the wine dataset from scikit-learn. This dataset contains chemical analysis of wines with 13 features. We drop the target column because clustering is unsupervised and we don't want the labels to guide the model. Next, we set up clustering environment. We use pycaret setup function. We normalize the data so all features are on the same scale. We use GPU support for faster computation. This step prepares the data for modeling and applies pre-processing automatically. Next, we create and compare models. We create a k-means clustering model using create model k-means. Pycaret also allows us to see all available clustering algorithms with models function. Next, assign cluster labels. After training, we assign cluster labels to the data using assign model. Each row in the dataset now has a new column called cluster, indicating its group. Next, analyze the model. We visualize the clustering results with pycaret's plot model function. Elbow plot helps determine the optimal number of clusters. Silhouette plot shows how well the clusters are separated. Cluster plot visualizes data points in clusters. Optionally, evaluate model provides an interactive dashboard for deeper analysis. Try another model. We can also create a mean shift clustering model as another approach and visualize the results to compare performances. Next, inspect configuration. We can check and modify internal configurations of pycaret like random seed, which ensures reproducibility of the results. Save and load model. Once a model is ready, we save it in save model and we can reload it later with load model and predictions without retraining. Next, predict on unseen data. Finally, we use the train model to predict clusters from new unseen data. We can see which cluster each new sample belongs to using predict model. Conclusion. Overall, this collab demonstrates a complete clustering workflow from data preparation to model training, evaluation, and saving the model for future use, all using pycaret, which makes the process simple and efficient. Thank you.